There are at least 30 documented sites across the planet where gravity appears to behave differently, where water flows uphill, where compasses go haywire, where physics, as we learned it, doesn't seem to apply. Some of these have been explained by science, some haven't, and a handful are anomalies so strange that researchers have quietly stopped trying. In the next 10 minutes, we're going to 6 of the most extreme. And by the end, I promise you, the ones that turn out to be illusions are somehow more unsettling than the ones that aren't. Let's establish the science first, because it matters for everything that follows. A gravity hill, also called a magnetic hill or mystery road, is a location where the layout of the surrounding terrain creates a powerful optical illusion. The road appears to slope downward, but it actually slopes upward. Your brain uses the horizon and surrounding features, trees, hills, fences, to judge incline. When those visual cues are misleading, you get fooled. This was first formally documented in the 1930s. By the 1960s, physicists had largely explained the most famous examples in the USA and Europe. But, and here's what the mainstream coverage never tells you, not all of them fit that model. There's a subset of gravity anomaly sites that involve measurable magnetic field distortions, sites where electronic compasses fail, where metal objects behave strangely, and where the explanation isn't an optical illusion. It's something underneath the ground. Lake Wales, Florida. Population, 16,000. Home to a street so strange, it's been confusing drivers for over a century. Spook Hill is one of America's oldest tourist curiosities. The legend, told by the Seminole people long before the road was built, involves a great alligator and a native chief whose battle disturbed the land so much that the hill itself was cursed. The modern explanation is less dramatic, but no less interesting. The road was cut through a landscape where the natural horizon reference is completely destroyed. The surrounding terrain slopes at an angle that makes a slight uphill incline look like a descent. It's not anti-gravity, it's your visual cortex being tricked at a neurological level. NASA has used Spook Hill as a teaching tool. When you're in an environment where all surrounding cues point the wrong way, your brain cannot override the illusion. Even when you know what's happening, the car still looks like it's going up. The compass is fine in Lake Wales. Nothing unusual underground, just geometry, and the profound realization that human perception of down is more constructed than real. If that already broke your brain a little, hit the like button. It helps more than you think, and we're just getting started. Now we go somewhere the optical illusion explanation starts to crack. Magnetic Hill sits at 14,000 feet in the Himalayas, on the Leh-Kargil Highway in Ladakh. It is one of the most studied gravity anomalies in Asia, and it has a second layer of strangeness that has kept researchers returning for decades. Like Spook Hill, the road appears to slope down. Park your car, release the brake, and it will roll uphill at speeds of up to 20 kilometers per hour. The optical illusion explanation applies here too. The surrounding barren terrain offers almost no reliable horizon reference. But here's where Magnetic Hill earns its name. Multiple independent surveys have recorded genuine geomagnetic anomalies in this region. The Ladakh terrain sits on one of the most geologically active zones on Earth, the collision boundary between the Indian and Eurasian tectonic plates. Subsurface iron-rich rock formations here are dense enough to measurably affect compass readings. Is the magnetism causing the rolling sensation? No, the optical illusion is still the primary driver. But the presence of real magnetic anomaly beneath this site raises a more interesting question. Could there be locations on Earth where both effects are happening simultaneously? Where the illusion masks a real, smaller gravitational pull being generated by subsurface mass? Geophysicists call this a gravitational anomaly. They happen everywhere, but most are too small to feel. Magnetic Hill, Le, sits at the edge of where it gets hard to separate one from the other. We need to talk about Norway, because Hessdalen is in a category of its own. Since the 1930s, and documented intensively since 1981, the Hessdalen Valley has been the site of persistent, unexplained light phenomena. Lights that hover, move slowly, change color, disappear, and have been recorded on thermal, radar, and magnetometric instruments simultaneously. This isn't a gravity hill. The cars aren't rolling uphill here. But Hessdalen belongs in this video because it represents something more important. A site where measurable electromagnetic anomalies are so strong, so repeatable, and so scientifically verified that they've forced physics to take seriously the idea that Earth's crust can generate field effects we don't fully understand. The leading hypothesis, developed by Italian physicist Massimo Teodorani, is that Hessdalen sits above a sulfide mineral deposit in the bedrock that, under specific humidity and ionization conditions, generates piezoelectric discharge. Essentially, the rocks themselves produce electricity. The plasma this creates is what people see as lights. What makes this relevant to gravity hills and magnetic spots is the implication. If the ground beneath certain locations can generate plasma through pressure and mineral composition, it can almost certainly generate localized electromagnetic fields strong enough to distort instrumentation, animal behavior, and possibly human spatial perception. In other words, the line between optical illusion and something physical happening is thinner than we're comfortable admitting. We're past the halfway point, and if this is the kind of content you want more of, subscribing right now literally tells the algorithm to keep showing you this channel. Takes 2 seconds. Let's bring the science together, because this is where it gets genuinely strange. Gravity at its core is simple. Mass attracts mass. Earth's gravitational field is roughly uniform. Roughly. In reality, Earth's gravitational field varies by location, altitude, and what's underneath you. This is called a gravitational anomaly, and space agencies, including NASA and ESA, have mapped them from orbit using satellites. The variation is tiny, typically measured in milligauss, but it's real. There are places on Earth where gravity is measurably weaker or stronger than average, driven by variations in crustal density. The Himalayas, for example, have a strong positive anomaly from the subducted plate mass below. Now here's the question. Could a gravity hill site ever overlap with a genuine gravitational anomaly? Could the optical illusion be amplifying a real, small, physical effect? The honest answer from geophysicists? Yes, in theory. No documented case has proven a meaningful correlation, yet. But the data resolution of most gravity surveys is too coarse to rule it out at the small scales these sites operate on. What we know for certain: the human vestibular system, your inner ear, your balance, can be influenced by magnetic fields. Studies on migratory birds showed this. Studies on humans in MRI machines showed mild spatial disorientation. At what field strength does this become significant? We don't know. That experiment hasn't been run at Gravity Hill sites. It probably should be. Let me give you the uncomfortable part. Of the 30-plus documented Gravity Hill sites globally, the optical illusion framework comfortably explains about 80% of them. Surveyors can measure the incline, model the horizon distortion, reproduce the effect in labs. Clean. But there are a handful. Electric Bray in Scotland, the Mystery Spot in California, Cosmos Mystery Area in South Dakota, where the illusion explanation is incomplete, where visitors experience not just visual confusion, but physical sensations, nausea, vertigo, a pulling sensation with no visual trigger. Electric Bray has been surveyed 7 times with modern equipment. The incline is confirmed. The road goes uphill. The visual explanation is confirmed. Surrounding fields and the sea horizon create a reliable illusion. But independent measurements of the magnetic field at Electric Bray show a consistent, mild anomaly, not from any industrial source, from the rock below. Nobody is claiming this is anti-gravity. Nobody is claiming something supernatural. What researchers are saying, carefully in peer-reviewed language, is that the full physical picture at these sites is still open. And that honestly is the most interesting thing about Gravity Hills. Not the illusion, not the legend. The fact that in 2026, there are still places on Earth where the complete physics hasn't been written yet. Earth is a planet with 4.5 billion years of geological history, compressed plates, mineral deposits we haven't mapped, electromagnetic fields that shift, decay, and surprise us. The idea that we've fully explained what down means or where gravity takes unexpected forms might be one of the most quietly arrogant assumptions in modern science. The gravity hills are real. Most of them are illusions. Some of them are more than that. And the line between the two is exactly where the most interesting science lives. If you want to go deeper, we made a video on the underground cities that defy conventional engineering logic, built thousands of years before we had the tools to explain them. That video is right here. I'll see you there.